Hello, I welcome you all in this presentation related to the subject joining technologies for the metals, and this presentation is mainly based on the sealed metal arc welding process and the base fundamental principles of the arc welding in general. So, we will try to first of all understand that how the heat is generated and how it affects the quality of the weld joint in general. So, here for establishing a welding arc for welding purpose, what is important that the between electrode and the base metals to be joined, a stable arc is established, and for this purpose normally the electrode and workpiece are connected to the suitable power source. Say the work electrode is connected to the negative terminal and workpiece is connected to the positive terminal, and with the suitable power supply, when the arc is striked, the current flow takes place. But we know initially when there is no arc, the gap between the electrode and workpiece is full of the atmospheric gases, and the gases are non electrical conducting. So, this gap must be made electrical conducting, and for that purpose only we have to use certain arc initiation methods, and these arc initiation methods basically rely on developing the charged particle column between the electrode and workpiece, so that it can be made electrical conducting. And these there are two methods which are extremely commonly used. One is touch start method and another is field start method. In case of the touch start method, electrode is brought in contact with the workpiece for striking the arc or for initiating the arc, and as soon as the touching takes place, due to the short circuit, high flow of the current results in the excessive heat generation at the contact points. So, increase in temperature at the contact points of the electrode and workpiece, and once this heating takes place due to the short circuiting, in this very short period, maybe sometimes partial melting, evaporation, means metal vapor generation, all this takes place in a very short period of time, and once the short circuiting is over, the electrode is taken away from the workpiece. So, gap is created, this gap is full of air. So, here once the gap is created, the open circuit voltage, means the arc voltage is the potential difference between the electrode and workpiece is established, and in this situation what happens that due to the heating, thermal ionization or thermal emission of the electrons from the electrode tip and workpiece side, at the same time ionization of the metal vapors takes place, which were generated due to the during the short circuiting period, and these as a result of thermoionic emission, electrons are produced, and ionization of the metal vapors produces positively charged particles and negatively charged particles in form of electrons. Since we had connected the workpiece and the electrode to the power supply with the particular kind of the polarity. So, here as per their polarities, the anions will start moving towards the cathode, that is the electrode, and electrons will start moving towards the anode, that is the workpiece. So, this is how the flow of charged particles, movement of charged particles in the arc gap starts, and once sufficient charged particle density is available in the gap between the electrode and workpiece, it becomes electrically conducting, and once the gap has become electrically conducting, the flow of current starts. So, this is how the arc initiation takes place in case of the touch start method, and in case of the field start method, high strength electromagnetic field is established between the workpiece and the electrode, and so this high strength electromagnetic field helps emission of the electrons from the surface of the cathode, and this in turn produces the charged particles in the gap. In this case, no direct contact between the electrode and workpiece is needed, but the development of high strength electromagnetic fields helps in emission of the electrons from the cathode, and that is how the gap is made full of the charged particles, and the gap is made conducting. So, the important thing for having a stable arc is that the gap between there is a sufficient potential difference between the electrode and workpiece, and the gap is made conducting. In the event when the gap is deficient with these charged particles, means charged particle density is less, then the reduced electrical conductivity will be leading to the extinction of the arc, means arc may get extinguished in that situation. And if it is really full of the charged particle, means the charged particle density is high in the gap, then it will be leading to the very good electrical conductivity, and the flow of current through the arc will be very smooth. So, that will keep on. So, that flow of current through the arc, that is a welding current, and the that arc voltage potential difference, means that is difference between the electrode tip and the workpiece, is the arc voltage. Product of these two gives us the power of arc, and this power of arc helps in generating the heat desired for the melting of the workpiece. So, there are two methods for initiating the arc, and these are the conditions which are necessary for emission of the starting starting the arc or initiating the welding arc. And these two methods are used invariably in most of the welding processes. For example, touch start method is commonly used in processes like shielded metal arc welding process, that is manual metal arc welding process, also in the gas tungsten arc welding process, and like the gas metal arc welding process, and like submerged arc welding process, electro slag welding process. In all these processes the touch start methods, but sometimes if it is felt that the contact between the electrode and workpiece is not good from the soundness point of view of the weld joints, in that case, like say the tungsten gets transferred at the time when there is a contact between the workpiece in case of the GTAW process. So, the tungsten inclusions are formed in case of the GTAW process if the tungsten electrode tip is degraded and gets transferred to the weld pool. So, it will be contaminating to the weld with the tungsten inclusions and adversely affecting the mechanical properties. And another possibility is that when we do not want that direct contact between the electrode and workpiece is either not favorable due to the possibility of the contamination and inclusions of the weld, or it is not practically possible to have the contact of the electrode with the workpiece like in the plasma welding. So, in those situations the high strength electromagnetic field is established for initiating the arc. So, without so in that case the electrode is not brought in contact with the workpiece for initiating the arc. So, plasma welding and all other automatic gas tungsten arc welding, wherever we find that the contact is not suitable, or in automatic welding processes where it is not feasible, automatic welding wherever automation has been implemented. So, we want that arc is initiated without direct contact by feeding the electrode to the workpiece for making the contact and initiating the arc. So, these are the two ways by which arc is initiated as far as. So, these basics are applicable for entire range of the arc welding processes. Now, we will see the things related with the shielded metal arc welding process, commonly abbreviated as SMAW. In case of the SMAW, what we use? We use one electrode which is normally coated with the flux. This plays a very big role in case of the shielded metal arc welding processes. Here we have core wire of the electrode and this is flux coating on the electrode. Flux coating in the shielded metal arc welding process plays a very important role for success of the process. And here in this case, since the touch start method is used and mostly the process is controlled manually, so the power source used with this process is of the constant current type, means even the short circuit stage it does not offer much higher large current value, like this is the kind of the VI characteristic or the static characteristic of the constant current power source here. So, the in short circuit stage the current is limited and also there is no major change in the value of current with the fluctuation in the arc length which will be changing the voltage. So, despite of marginal change in the arc length, the current does not change appreciably. So, it maintains the heat, it maintains the consistency in the heat being generated for uniform melting and good quality of the weld joint. So, it is preferred to have the constant current type of the power source and mostly the type of current as far as for this process is concerned, it can be AC or DC. DC is very commonly used because it can be invariably used with all types of the electrodes like rutile, basic and the cellulosic type of the electrodes. All these electrodes are extremely common in the industry for the welding purpose and these can easily be used using the DC welding current. For using AC, what is required that for the welding electrodes for AC needs the special care, especially in terms of the low ionization potential elements. These low ionization potential elements must be present in the electrode in sufficient quantity like sodium, potassium and calcium. So, these low ionization potential elements facilitate the easy emission of the electrons for striking the arc whenever current passes through the 0 level or the changes the direction or the voltage is 0. So, if this is the current cycle and this is the voltage cycle in case of the V's in case of the AC. So, it is important that when the current flow when using AC becomes 0 at this stage to have the gap conducting the sufficient charge particles has to be produced so that the gap can be maintained electrical conducting and for that purpose low ionization potential elements are you see they are very important for good arc stability. That is why the AC should be used keeping in mind the recommendation of the manufacturer for shielded metal arc welding electrodes. So, this is about the power source and the type of current which is to be used. Now, the role of the coating, since if we see here the bare electrode is open at the top, electrode at the top end is bare where there we do not have the coating and the entire length otherwise it is coated. This length may be like say 250 to 400 mm and the diameter of the electrode is designated through the diameter of the core wire in mm like say. So, it is very common to have like 1.6 to 2.5, 3.15, 4, 6.3, 8, 10 mm diameter electrode. So, all these are indicating the diameter of the core wire. So, electrode diameter means the diameter of the core wire and this is the coating. So, the diameter of the electrode with the coating is if indicated by the letter D and the diameter of the core wire is indicated through the letter small d in that case the ratio of the core diameter of the electrode with the coating divided by the diameter of the core wire. This ratio gives us the idea about the coating factor. Coating factor is an indicator of the thickness of the coating layer which has been applied over the surface of the core wire. So, this coating factor value generally varies from 1.2 to 2.2, wherein light coated electrodes means the coating is very thin. Light coated electrodes, they have this value from 1.2 to 1.35. Medium coated electrodes will have this value in the range of 1.4 to 1.7, and then heavily coated electrodes, they will have value from 1. Say greater than 1.7 to 1.2.2. This is the general, just to have the idea about the range. So, now it is very easy to understand the light coated electrodes will have very thin layer of the coating, and this thin layer of the coating may not be enough to provide the sufficient shielding to the pool. So, for that we need to see that what are the roles being performed if the coating is thin or if the coating is really very thick. So, thickness and thinness of the coating will have the effect on the soundness of the weld joint. So, for that how it will affect, that is what we can see in respect of the the kind of role which are performed by the electrode coatings during the welding. So, as far as the role is concerned, the bare electrode, we know bare electrode like of the iron or aluminum, they are having higher ionization potential. So, the electron emission capability is very limited. So, they do not provide very smooth and stable arc due to the limited electrical conductivity of the gap between the electrode and the workpiece. So, the arc is unstable mostly in case of the bare electrode, and that is why the electrodes if they are coated with the then the coatings of the low ionization potential elements, coating with the low ionization potential elements will provide the arc stability. Though the first role of the providing, which is very important, the purpose of providing the coating is first to see that arc is stable. So, and this is achieved through the incorporation of the low ionization potential elements like sodium, potassium, calcium in the coating. These elements have very low ionization potential, and that is why during in the welding conditions, during the welding they emit the electrons very easily and provide the conducting gap between the electrode and workpiece easily. So, the arc stability improves, and the second purpose is to provide the deoxidizers. So, it is common like ferro manganese and silicon kind of things are added. What they will be doing, they will these whatever oxides are being formed, it will help to separate out the metal which has got oxidized, and help to save the metal worth, and then also to provide the flux for removing the impurities, like the flux is designed in such a way that the ingredients or constituents of the flux interact with the impurities and form slag, and this slag is designed to be lighter than the weld metal. So, whenever the weld metal weld pool is formed, the slag which is formed due to the interaction between the flux and the impurities, the slag becomes lighter and it starts floating over the surface of the metal. At the same time, this the coatings are also provided for controlled alloying, controlled alloying. If it is required to have the specific set of the properties in the weld metal and we want to incorporate some special elements like chromium or molybdenum in the weld metal, then these elements are incorporated with the coating, and when in the powder form, and when these will be then these will be transferred to the weld pool. So, this is what is called controlled alloying, and so the alloying elements which we want to incorporate in the weld metal, they will be added in the coatings, so that during the welding these get transferred after the fusion into the weld pool. Further, this is also used for increasing the deposition efficiency, and how it is achieved, like the iron powder cell, if the steel is being welded, to increase the deposition efficiency, iron powder is incorporated with the coating, and when this iron powder melts, it gets transferred to the weld pool. So, coating efficiency, because is calculated from the weight of the core wire, and when the iron powder is added with the flux, it helps to increase the weight which is being deposited in unit time, and thereby it helps to increase the deposition efficiency or the deposition rate. Rather, it is deposition rate. In unit time we are able to deposit more quantity, because iron powder will be getting transferred after melting into the weld pool, and the iron powder which was incorporated with the coating, in that way it helps to increase the transfer of the in that way it helps to increase the deposition rate. There are few more functions which are performed by these coatings, which includes like in odd position welding or in vertical welding, like this vertical or overhead welding conditions, where there is a heavy tendency of the molten metal falling from the weld pool. So, in this case it is desired that viscosity of the weld metal is high. So, the slag which is actually the flux is designed in such a way that the slag which is formed is thick and viscous. So, its the falling tendency of the weld metal can be reduced. So, basically the purpose of the coating can also be to adjust the viscosity and surface tension of the slag and molten metal, so that the flux the falling tendency of the weld metal during the welding can be reduced. So, these are the important functions which are performed by the fluxes. Which are applied in the coating. There are different types of the constituents which are added in the coatings, and these are commonly used as a low ionization potential elements like sodium, potassium, calcium. There is a charcoal which is commonly added, and then sawdust is also used, various hydrocarbons, and commonly used as a binder. These are sodium or potassium silicates. There are number of constituents which are added for performing the specific functions during the welding, and that is what we can see from this slide, wherein this list shows the different elements and which are added into the flux for performing the specific functions. For example, quartz is added for increasing the current carrying capacity, magnetite is added for refining the transfer of the molten metal drops, means that it helps in achieving the split transfer, and calcium carbonate is helps in reducing the arc voltage and providing the inactive gases, so that the arc can be or weld metal can be protected, and fluorspar for increasing the viscosity of the slag and molten metal. Ferromanganese and ferrosilicons are commonly used as deoxidants, and the cellulose for releasing the shielding gases, and potassium water silicate, these are the bonding agents, and the rutile is also one of the common element which is added in form of the titanium oxide for increasing the viscosity, and since it has a very good arc emission capability, so it helps in restriking of the arc. So, one of the important functions of this flux is also is that when this coating when approaches to the arc in course of the welding, it is burned out. So, burning of the coating produces burning of the coating or combustion of the coating material produces lot of inactive gases in form of CO2 and CO. So, these gases are released due to the thermal decomposition of the coating constituents and combustion. So, these gases form actually very loose cover of the CO and CO2 around the welding arc, and thereby it helps in protecting the weld metal from the atmospheric contamination. So, this is very important role of providing the coating in the shielded metal arc welding processes. Since the protection provided in this process is not very good, because it forms very loose cover. So, there is every possibility that the atmospheric gases will be able to interact with the weld metal during the shielded metal arc welding process, and that is why usually the concentration of oxygen and nitrogen in the weld is on the higher side, and normally say these are found like 0.1% to 0.08% or side. So, the higher concentration of the oxygen and nitrogen in the weld metal, they tend to degrade the properties of the weld joint, and that is why these are good for like say for shielded metal arc welding process is good for the general purpose welding, and wherever you see non critical applications of the welding, because the quality of the weld joint is not that good, and high due to the higher concentration of the gases, only this process can not be used for the purpose of the welding of the reactive metals like aluminum, magnesium, chromium or the stainless steel, because these metals easily react with the oxygen and form their oxides which are refractory in nature, and these oxides do not melt easily, therefore, they interfere with the melting of the base material, and these oxides also get mixed up with the weld metal to form the inclusions. So, the problems are there are many problems associated with the welding of the reactive metals using shielded metal arc welding process, that is why they are not normally welded with the shielded metal arc welding process, and more those processes which provide more effective protection to the weld pool are normally preferred for the welding purpose of these reactive metals like gas metal arc welding process or gas tungsten arc welding or the plasma welding process like those. So, this is now I will conclude this presentation. In this presentation I have talked about that how the arc is established, how the arc is initiated, what are the conditions necessary for striking the arc and having the stable arc, and what is the role of the different coatings and the electrode in the shielded metal arc welding process, and what kind of metal systems which can be welded using this process. Thank you for your attention. In the next presentation I will talk about the other welding processes like submerged arc welding process and gas tungsten arc welding process. Thank you for your attention.